Welcome back, math enthusiasts. If you missed part 1 of our captivating journey through grade 12 calculus and vectors, MCV4U, lesson 2 on limits, worry not, we've got you covered. In part 2, we're delving even deeper into 1.3 limits, with a focus on more examples to enhance your understanding. In part 1, we explored the significance of limits in calculus and learned valuable techniques to evaluate them. Now we're taking it a step further, building upon the concepts covered previously. Our experienced team at Gifted Academy Tutors has curated a collection of real-life examples that will help solidify your grasp on limits. Whether you're a student, a learner, or an expert honing your math skills, this video is designed to cater to all levels of learners. So, get ready to conquer limits and unleash the full potential of calculus. If you haven't seen part 1 yet, don't worry. You can still jump right in and join the journey. Don't forget to like this video, subscribe to our channel, and hit the notification bell to stay updated with our latest content. We're here to support you on your quest for mathematical mastery. Let's continue with Lesson 2, Part 2. More examples on limits. Happy learning!
So this is the in continuation with the topic limits, and our topic is properties of limits. So if we have any real number a and we have two functions f and g and both have limits at a, for any real number a, suppose that we have function f and g, and these both functions have limits and it exists at x is equal to a, then we can define these properties for the limits. The first property is limit x tends to a, k is equal to k for a constant value. If we have any constant value, if we apply the limit for that, the limit will be the same, because if we have a continuous function, a constant function, so the constant function, the value will be the same for all the points. So if we take the limit at any point, it will reach to the same constant k. This is to explain. The next is if we take limit x approaches to a for function x, so it will be equal to a. We directly put the value a in the function. The next is limit x approaches to a, fx plus minus gx will be equal to limit x approaches to a, fx plus minus limit x approaches to a, g of x. So we can take the limit for the two functions and subtract or add them as per the given. The another property is, if we have a limit x approaches to a and we have some constant term with a function fx, so we can take this constant term out and we can take directly the limit of function. For any constant c. Another property, if we have two functions in multiplication, like we are taking the limit x approaches to a fx into gx, these two functions are in multiplication, so we can take the limit separately for these two functions and multiply it. The limit of fx, and we can multiply with the gx. Next is, we have limit x approaches to a. Similarly, we have this function. One is numerator, another is denominator. So we can take the limit separately. The one thing there should be provided that these things must not be 0, otherwise this will not be defined. The gx limit must not be 0. The next property is, limit x approaches to a fx to the power n. We can take the limit inside the power. It might be the fractional power or the complete power. For any rational number. So these are the few properties of the limit. So we can take an example. So solution for this example, using the limit property to evaluate the limit of the polynomial function, we have to calculate the limit of x tends to 2, 3x square plus 4x minus 1. So it is a function, it is combining the few properties. So we can take, these are in the addition, so we can take the limit of all the functions individually. Now these two things are multiplication, so we can take the constant out. Here also we can take the constant term out. As we studied, the limit of a constant value is a constant value, so it is the 1. Now it is a x to the power n or some n function to the power n, so we can take the limit and function to the power n, like 3 limit x approaches to 2x square, here it is x, plus 4. When we apply limit x approaches to 2 for x, it will come 2 and minus 1. Similarly here it becomes 2. 3 multiply 4 plus 8 minus 1. So it comes out 12 plus 8 minus 1, which is 19. So if we look at this example, so we are using here the different properties. Use properties of limit. We can take another example also. In this example, we have two functions, one is numerator and another is denominator. So we can take the limit of numerator and denominator separately, and we can use the different properties of the limit to calculate the value. We can write it, the limit of numerator and denominator separately. After that, we can apply the properties. So we can take the limits of each and every term individually. It is x square minus x tends to minus 1 5x plus limit x tends to minus 1 2 limit x tends to minus 1 2x cube plus limit x tends to minus 1 3x plus x tends to minus 1. Now we can use another property to expand this expression. We can write whole square minus 5 x tends to minus 1 x plus, so for the constant value we can directly write the constant value because we put the value in the variable x. I can write directly, it is this term, to limit x tends to minus 1 x cube plus 3 x tends to minus 1 x plus 1. It becomes minus 1 square 5 minus 1 2 minus 1 cube plus 3 minus 1 plus 1. It becomes minus 1 square become 1, and multiplication of 5 and minus 1 becomes plus 5 here, 2, and here this term becomes 2 minus 1, and it becomes minus 3 plus 1. It becomes 8 and it becomes minus 4, and the final is minus 2. For this question the answer is minus 2. We apply the simple properties of the limit and calculate the limit. Now we can take one more example. Here we have given a function which is under the root function. So root function basically is the power. So we can take the limit inside the power. So we can take the limit inside the root. So we have limit x approaches to 5 square root of x square minus 1. As per the property, I can take limit inside the power or inside the root. So limit x tends to 5 x square upon x minus 1. Now I can take the limit of denominator and numerator separately. So it becomes limit x approaches to 5 x square over limit x approaches to 5 x minus 1. We can take for the power, we can take the limit inside. For the numerator, we can do the same. X tends to 5 x square over. In denominator, we have x value and 1 constant value. The constant value is 1. When we apply the limit, it becomes 5 square 5 minus 1. It becomes 25 over 4, and the square root of 25 becomes 5, and square root of 4 is 2. So in this question, we take the limit inside of the root and then do the numerator and denominator separately.